Today, we're gonna tackle a really cool engineering puzzle. Why can't you just start a giant electric motor the same way you flip on a light switch? Well, the answer involves a pretty powerful and, honestly, a potentially destructive force of physics. So let's get into it.
You've definitely seen this before, probably in your own house. The AC unit kicks on, or maybe a big power tool in the garage starts up, and for just a split second, all the lights flicker. Well, that tiny little dimming effect, that's actually a miniature version of the massive problem we're talking about today.
Because here's the deal. When a big motor starts from a dead stop, it doesn't just ask for its normal amount of power. Nope. For a very brief moment, it demands 5 to 7 times its rated current. That is a colossal, almost violent surge of electricity.
And this surge has a name. It's called inrush current. You see, when a motor is at a standstill, electrically, it looks almost like a short circuit. And that's what causes this huge draw. So the challenge becomes pretty clear. How in the world do you get a massive motor spinning without that initial surge wrecking the motor itself or causing a huge voltage sag for everyone else on the power grid?
So, here's our game plan. We'll start with the simplest, most direct method. Then we'll walk through some really clever old-school solutions. And then we'll dive into the high-tech electronic controls that we use today. And at the end, we're going to put them all side by side so it all makes perfect sense.
All right, first up is the most basic approach you can possibly imagine. We're talking about the brute force method, which is officially known as direct online starting, or just DOL. The idea here is about as simple as it gets. You connect the motor directly to the full power supply and just let her rip. I mean, it's super cheap, it's easy to implement, and it gives you the absolute maximum starting torque possible. But, and this is a big but, the trade-off is severe. You get that massive electrical surge and just incredible mechanical stress on the motor and whatever it's connected to. This really only works for smaller motors where the power grid can actually take the hit.
So for any of the bigger motors, engineers needed to get a lot more clever. And this brings us to our next category, the classic methods that were specifically designed to reduce the voltage during that supercritical startup phase.
And probably the most common of these is the star-delta starter. It's a really ingenious two-step electrical trick.
Okay, here's how this magic works. The motor starts up with its internal wiring connected in what's called a star configuration. Now, this simple change is the whole key. It reduces the voltage across each part of the motor to about 58% of the normal voltage. This dramatically cuts both the starting current and the starting muscle, the torque, down to just 1/3 of their full values. Then, once the motor gets up to about 80% of its full speed, a simple timer just flips a switch, reconnecting the wiring into a delta configuration to run at full power.
So the crucial takeaway here is the compromise. Star Delta is a fantastic and cheap way to solve the high current problem, but you pay for it with a massive cut in your starting torque. This means it's only really good for loads that are easy to get moving, like maybe a fan or a pump that isn't under load yet.
But what if you need more torque than a star delta can give you? What if you have a tougher load? Well, that's where our next classic solution comes into play, the auto transformer starter.
Instead of a fixed one-size-fits-all reduction, this method uses a special kind of transformer that has multiple taps. You can think of it like having different gears. It allows an engineer to pick a specific starting voltage, like say 65% or 80%, to perfectly match what the load needs. It gives you a lot more torque for every amp you pull from the grid, which makes it much more flexible. So what's the catch? Well, this hardware is big, it's heavy, and it's quite a bit more expensive.
And that brings us to the modern era. We're now moving away from these clever but kind of clunky mechanical switches and into the world of power electronics. This is all about using silicon brains instead of just raw brawn.
First in this category is this soft starter. And you know what? The name is perfect. It's the smooth operator.
A soft starter uses power electronics to basically act like a very sophisticated dimmer switch for the motor. So instead of a sudden jolt of power, it gradually and smoothly ramps the voltage up from 0 all the way to full over a time you can set. The result is this beautifully smooth, stepless acceleration. That's why it's perfect for things like conveyor belts. You don't want to jerk the belt and have everything fall over, or for large pumps, where it prevents a damaging shock wave in the pipes that's known as water hammer.
And now let's look at the absolute king of motor control, the variable frequency drive, or VFD. Now, while a VFD is mainly known for controlling a motor speed after it's running, it also just so happens to be the most advanced starting method there is.
A VFD is a complete game changer. It basically creates a brand new, perfect power supply for the motor, letting it control not just the voltage, but also the frequency. By starting at a really low frequency and then ramping up, it can deliver nearly full torque from a total standstill, all while drawing barely more than the motor's normal running current. It solves both problems at the same time. It crushes that high starting current while actually providing better starting torque. It's the best of both worlds.
So we've seen everything from the simple hammer of the DOL starter to the surgical scalpel of the VFD. Let's put them all together now in one final comparison to see how you actually choose the right tool for the right job.
You know, seeing all the trade-offs in one place like this really makes things click. DOL is cheap and simple, but it's harsh. Star Delta is that clever compromise that cuts the current, but it also kills your torque. The auto transformer gives you that nice adjustability, but for a higher price. The soft starter is all about that smooth ramp-up. And finally, you've got the VFD, which gives you total control, but it comes with the highest cost and the most complexity. And that really leads us to the most important takeaway of this whole thing. There's no single best starter. A VFD might seem superior on paper, but for a simple farm irrigation pump that only runs a few times a year, a cheap, reliable Star Delta starter is often the absolute perfect choice. It is always a balance between the application, the performance you need, and of course, the budget.
So the next time you're in an elevator and you experience that perfectly smooth acceleration, or maybe you see a massive industrial fan spin up without a single clunk or flicker of the lights, you'll know exactly why. It's not magic, it's just a really sophisticated solution to that fundamental problem of inrush current. So the question is, can you guess which one it is?